Let's explore how we can use logarithms to solve for variable exponents when the variable, like x, is in the exponent spot. This is going to be very helpful when getting the same base on both sides looks like it's going to be a very difficult thing to do or impossible to do. So these equations are easy to solve right here because we can get the same base on both sides. That's been our strategy so far all along. You might be able to solve these ones in your head. 4 to the x power equals 64. Well, 64 is a power of 4. 4 to the x power equals 256. 256 is also a power of 4. So we can change 64 to 4 to the third power, same base on both sides. We can change 256 to 4 to the fourth power, same base on both sides. That means we can drop the bases and set the exponents equal to each other. And we can tell that the answer to the first equation is x equals 3. The solution to the second equation is x equals 4. Once again, not very tough to do because we could get the same base on both sides. But what if it isn't easy to get the same base on both sides? Look at this purple example. 4 to the x power equals 140. 140 is not a power of 4, and we're not going to divide both sides by 4 or by 4 to the x power. That's not going to help us out. We can tell that the answer's got to be between 3 and 4 because 4 to the third power is 64 and 4 to the fourth power is 256, and 140 is between 64 and 256. But we would have to guess and check for a very long time to figure out what that crazy decimal might be. How are we going to figure this out? Logarithms will come to our rescue. Here's how we're going to solve 4 to the x power equals 140. It's the way to solve when you have a variable exponent. And it's going to be too hard to get the same base on both sides. So again, the variable is in the exponent spot. For most of your algebra careers, the variable's been down here with everything else. But now it's in the exponent spot. Our first step is to introduce logarithms to both sides of the equation, specifically log with base 10, because that's what's loaded into your calculators. So it used to be 4 to the x power equals 140, so we'll take log, again, of base 10, 4 to the x power equals log, base 10 of 140. This will work out just fine because if two values are equal, their log base 10s must be equal. And that takes us to our main strategy. We know if we have an exponent with this logarithm, we can take that exponent and move it in front to the coefficient position. And now we've got the variable down where we want it. Now we have x times log 4 equals log of 140. And it's a lot easier to solve for x now. We're going to divide by log 4 on both sides. And now this is ready to put into a calculator. In fact, this is calculator ready form. When you see this in the directions of your assignment, this is what your teachers are looking for. If you're careful with parentheses, starting them and ending them, you can be okay putting this into a calculator and you may not have to worry about any decimals that come up along the way. I went ahead and found log 140 and log 4 and just copied and pasted them. I went a little crazy with the number of decimal places, but I want to make the point, don't round early. We know our final answer is going to go to 3 decimal places. Don't do your work in the middle to only 3 decimal places. You might get some big rounding errors. So take it out to 4 or 5 decimal places. And again, I went extreme. I just copied and pasted what I got out of the calculators I was using. And then we'll get our answer. It's about, that's what this squiggly equals looking like sign is, it's about 3.565, which is what we were kind of expecting, something between 3 and 4. X is about 3.565. You try this one. Pause the video and solve 5 to the x power equals 900. Remember our steps. Introduce log to both sides, specifically log base 10. That's what's in your calculators. Move the exponent in front, and then divide to get a calculator-ready fraction that will give you the answer. And you should get x is about 4.227. I should have used a squiggle equal sign there. X is about 4.227. So we can use logarithms to help us solve when variables are in the exponent spot. And this will be very useful later in the course as we study exponential growth, exponential decay, and compound interest, because time will be in the exponent spot. And if we want to know how long something's going to take, we're going to have to use logarithms to help us solve those equations.